Okay. I think we're live. So, make sure before we go on. It says starting soon. Oh man, we're behind. So this is all going to be on the stream. That's exciting.
Yeah, that's okay.
All right. So,
I'm going to go on mute, and you can do awesome.
all right. So let's get started. Let's get that back there. So my name's Corvin Santo. I'm a senior developer for Portland Labs, the company that makes concretePHG, and I'm doing a talk on using Composer and building high-quality packages with it. So what's Composer? Composer will manage your dependencies. It'll distribute your code, and it'll even auto-load it all for you. So what does that mean? Composer manages your dependencies. You can actually choose from very specific versions of your dependencies. So if you want to pull in a beta or a release candidate of something and test it out, or if you want to get a major version from 2 releases ago, you can totally do that, and that'll all work. Everything's automatically resolved with Composer. So when you tell Composer to use an old version, it'll pull that version, it'll see what dependencies that version has, and it'll even pull those down too. And then finally, it's automatically available to all your code. So if you pull in a dependency with Composer and you're using Composer auto-loading, as soon as you run that Composer install, all of that's going to be available to your code, and you can make use of it right away. So how do you distribute code with Packagist, with Composer? Composer has Packagist. It's a website and API. It's kind of like the heart to Composer, the hub. Anybody can register a project as long as you have a repository for it that's public and you have a Composer JSON file in your project. So Composer handles all of your auto-loading, even for your dependencies. Check out these code examples that we have here. On the top, we have a composer.json file. It's hard to read, kind of, but we have a single dependency listed there, the monologue/monologue, and we're looking for version 1.0 whatever they have. And then we have an auto-load block in there that uses PSR4 and loads our stuff. So this is what a typical Composer JSON file will look like. And then there, that code block on the bottom is all of the PHP that you need to include in your project to make use of these dependencies and your auto-loading. So what kind of auto-loading can you do with Composer? PSR4 is the first one that we have listed. PSR4 is the 5th standard made by the PHP-FIG. It was released to kind of replace PSR0, which is a little bit old and somewhat antiquated. In fact, PSR0 is also an option, but you shouldn't use it because it's actually deprecated, and PSR4 will work better for you in almost every case. Next, we have a class map. You can auto-load using a class map. So what that means is you tell Composer to look in a couple directories for you, and when you run Composer install, Composer will find all of the classes in that directory, and it will take the paths and the class name and put it in a static file so that when you load in this vendor auto-load file, all it has to do is look through an array. Class maps can be useful if you have a lot of PSR4 namespaces and are running into issues with speed issues, or if you just don't like PSR4 or whatever. Class maps work real well. And then finally, the last setting that we have is file. And the way that works, Composer will just include a single file that you give it. So in that PHP file, you would just have a require or include for all of the things that you want to load in. So it's technically not auto-loading. So before we go any further, I want to show how simple and easy it can be to get started with Composer. So I just have a directory here. I'm going to make a new directory called C5 issues. Head into it and see it's empty. So what I'm going to do here, I want to make a quick script that is going to list out the latest concrete-5 GitHub issues. Usually, you'd expect to Google around for an API project that you can pull in. You'd copy that down, pull it in, and you'd require all the files that you need, and call it and everything. That would probably take an hour, at least. So with this, all we have to do is type composer require. It's going to ask me to search for a package. So I know I want a GitHub API v3 package. So it's going to search packagist, and it gives me a list of options. This search isn't very good. It doesn't really tell me much more beyond the name, but I already know that this KNP Labs GitHub API is the one I want to use. So I'm going to use that. And it asks me for the version. I just say enter, so I can let Composer decide on the version for me. So it chose to use version 1.6, and it's asked me if I want to find another package. I don't. So I just hit enter. Now it's finding all of my dependencies. It's actually pulling down. You can see it's installed KNP Labs GitHub API, which is what I wanted, but it also installed a couple of other things. Those are dependencies for GitHub API, so it resolved the dependencies automatically. So now, if we get rid of all of this and see what we have a composer JSON file, a composer lock file, and then just a vendor directory. So now, let's see if we can make use of that. So this is a little difficult to see, but I'm going to make a new PHP file here. I'm going to call it issue. Issues.php. Get rid of this. Now, this is just a PHP file. The first things we need to do, we just need to pull in our autoload. So require vendor/autoload. So now this is all we need to do. We've got Composer loaded. We've got all of our dependencies loaded. Now we can make use of that GitHub API. So I've already used this. I know how to use it. So I'm going to do just some quick code here. So now what we have a GitHub client that we create, and then we use this client to pull in all of our issues just by whatever the dependency has, and then we loop through them and output the title. So just like that, we're done. I can come back here. I see that issues.php file. I can run php issues.php, and immediately like that, I have a list of all of the issues that Concrete 5 has. It's not really all of them. This can be improved, but it took me 30 seconds. So that's how easy Composer can be just to get started with a project. You can get going really quickly if you know what kind of dependencies you have and what kind of thing you're wanting to end up with. So now that we've seen what Composer can do for your dependencies, let's kind of look at it from the other perspective. How are we going to distribute our code with Composer? So you might be thinking, open source is really cool. Let's start an open source project and test it out. But the first thing you should do is stop and take a step back. Not everything has to be made by you. So we often as developers want to keep everything in-house. We're interested in creating, so we want to create. But what we end up doing is that we give ourselves way too many projects to focus on, and we spread ourselves way too thin. when we have so many projects, we're almost guaranteed to let a few or all of them stagnate, and they're all going to suffer because our attention is kind of divided between many different problems. And a lot of the time, these things are things that we don't really have a real interest for. These are things that we thought would be fun. We thought it would be cool to spend some time and fix it, But really what we find out is that really we were interested in making it in the first place. We're not really interested in maintaining it or developing on the idea more. So then finally, a lot of the time when you're doing this, you're not contributing back to the ecosystem at all. Even if your code's open source, even if people are giving you pull requests and you're merging them and the project's secure, if you're not making updates to it, if you're not trying to push the envelope and stretch the idea, you're really not doing anything but existing. So adding another option to the ecosystem can really just clog things up, and potentially if there's somebody out there who maybe isn't spread too thin and might be really passionate about the issue, they might not choose to work on it because you're in the space and you're already taking up that market share. Open source is hard. People always ask me, they say, I've been working in open source. I have my code out there. People are using it, but people aren't contributing back. Well, the thing is, open source is not about necessarily getting people to help you. People won't help you, especially if you expect them to and require them to. If you're waiting on other people to do things for you for free, it's just not going to happen. Now, that's not to say that people won't help you. Some people will help you, but you got to give them a reason to help you, and you got to get them excited for your project. If people start using your software, they're going to trust you to keep it up to date and to keep it secure. If you just stop maintaining your project, you're going to be putting a real burden on real people who are just trying to get by. And like I said, unmaintained packages can be a much bigger detriment to the ecosystem than a lack of packages. Filling in the space and neglecting it is just going to make it harder for other developers to get started. So just search first. There's a lot of other developers out there who are probably smarter, probably better, and probably more passionate. So why not just find one of them to contribute with instead of finding one of them to compete with? Working with other developers who have different experiences and different passions is just going to make you a better developer, and it's just going to make you more well-rounded. So what are the components? Now that we've talked about how hard open source is, if we've decided to go into creating a composer package, how can we really identify which packages are high quality and which packages are low quality? Number one, I think, is clear licensing. This is kind of a odd one, I guess, but if you don't have your licensing clear, you're not necessarily open source. So if you don't have clear licensing, it could be the difference between getting users and not getting users. Your code's got to follow a standard. No matter what file I look in, I need to be able to know that it's going to be clearly formatted and it's going to look the same. I'm trying to read your code. I'm not trying to figure out what you were trying to type. Your code's got to be fully tested. A lot of the time when documentation falls short, I can run in and look at the tests because it's an itemized list of everything that a class is supposed to do. Fully testing your code can be really difficult, especially if you're not following design patterns that help you enable that stuff. But striving for the full coverage is going to help you make your code more flexible and just better. Your versioning has to be clear. This one's super easy. Just use semver. There's semantic versioning. Major, minor patch. And you got to have clear documentation. This is the hard one. This one's not really one that can just be solved by technical talent. So we'll look at that a little more later. And then you got to have reasonable minimum requirements. So minimum requirements are going to change depending on your project, depending on the space that you're in. But generally, you're going to want to make sure that your minimum PHP requirement is something that's supported by PHP, so that you're not encouraging people to use insecure versions. And then beyond that, you just want to make sure that your minimum requirements are going to open up the option for as many people to use it as possible. I know that Symfony, Drupal, Joomla, Laravel, and Concrete 5 will all be PHP 5.5.9 minimum starting with the next releases. So let's start with licensing. In my great country, United States, if you don't include a license, it just falls back to the copyright. So copyright's not open source. If you use something that's copyrighted, I have full legal right to come after you for that. So that's definitely not open source. Don't use a project that doesn't have a license. If they're open source, just open an issue and ask them, and they'll add it, I'm sure. If they don't, just use something that is open source. Use a standard license. It's not that hard to find one that's going to work for you. They're all pretty permissive, and I mean, if you find a project that you like and it's using a license, it's pretty much guaranteed that that license is going to work for you. But when in doubt, you need to talk to a lawyer, because most of us are not lawyers, and lawyers know what they're talking about. We don't. When in doubt, though, choosealicense.com is a really good resource, and it can kind of describe things to you in a really understandable way, help you decide. If you're a hipster like me, you might want to go against the mainstream establishment and use a vanity license. These are it's called copyleft, where it's completely against the copyright, where it kind of just lets you do whatever you want. The WTFPL, the do what the F you want public license, is probably the most permissive one. It says that you can do whatever you want as long as the name changes. If you're closed source, Composer's got some love for you too. There's a proprietary license tag that you can include, and that'll let everybody know that you're closed source. So code quality. If you could go ahead and use PSR2, that'd be great. So why care? Code needs to be readable. Imagine if you hired a writer who delivered a screenplay that is all written in terrible writing and misspelled words. You don't want to read through something and have to stumble over words and figure out what's happening. You want to read the content and see in your mind's eye what's going on. I don't need my brain to be spending resources trying to understand what words you were trying to use. When I switch from file to file, my brain just has no patience for inconsistencies. I need to be able to... Uh-oh. We lost our live connection here. There we go. When I switch from file to file, I need to be able to quickly understand what's happening in the code. I don't need to let my brain waste resources on trying to understand what stylistic changes there are. So having code standards helps with that. Some more practical reasons. It keeps your pull requests clean. If you don't have code standards, you're going to get pull requests that come in that add spaces, that remove spaces, that move stuff around. Even worse, if you try to add a standard later, every pull request that you get is going to be somewhat nonsense, because you're going to have to wade through style changes. And then you want to maintain your version control history. Your history suffers when you don't have a standard, because it turns into kind of a log of menial style changes instead of a history of actual functional changes. When you have a clear style guide that everybody follows, nothing in your Git history is going to show spacing changes. Everything's going to be functional changes, which will help you keep that clear. So I want you guys to imagine you got a friend working on a project. They want you to look at it. So they show you this. So I can imagine that everybody's sighing when they see this. You know, this is actually something that does have a coding standard. Everything's kind of formatted the same, but it's just all nonsense. If there's a parentheses missing in there, I'm going to be pretty upset. Just steal a standard. Use PSR1 or PSR2. Those were made by the Framework Interoperability Group for all of us so that we don't have to make our own standard. And if you don't like those, just find a standard that your favorite open source project uses, copy it, and paste it directly into your project, and you're done. Oh, but it's hard. It's really hard. It's not hard. Let the tools do the work. It's 2016. We should all be using an IDE. I use PHP Storm. It's great. I think it costs like $100 for a license. But NetBeans is free. I know a lot of people use NetBeans. So that's a great option. Sensio Labs has a great tool called CS Fixer. It follows PSR2 and will automatically detect issues with your code style and fix them for you. StyleCI.io and another website called Scrutinizer are both continuous integration tools that will look at your code repository and actually find issues with code style in there. So what's nice about StyleCI.io and Scrutinizer is when you get pull requests on GitHub, it'll tell you if there's any issues in there, and it will mark it as failed if there are. StyleCI.io can actually be set up to open pull requests when there are issues found, and I think it can even be set up to merge them too. Next, we got Fabricator. Fabricator is a project management tool. It's listed because it has a version control system command line wrapper, so it works with Git, Mercurial, and SVN. And when you open a pull request with Fabricator, this wrapper automatically does the code style check and will stop you from opening the pull request if there are issues. So then finally we have Git hooks, and that's kind of lets you do what Fabricator does on your own. Git hooks, if you use a pre-commit hook mixed with CS Fixer, you can, before you commit, every time automatically check your code style and fix it. On to testing. Testable code is clean code. If there are parts of your code that can't be tested, that's indicative of other API issues. Just write them as you go. Google was not tested in a day. If you want, you can even use something called test-driven development, which is essentially just writing the test before you write your code. You don't even need to follow that, but you should never move on to the next feature until the last one is fully tested. Keep your tests fast. You don't really notice slow tests until you're otherwise under pressure. Nothing's worse than failing a single test after passing 5 minutes of test, especially if you're going live in the next 5 minutes. Try to achieve 100% coverage. Remember this mantra: testable code is quality code. If you're not able to achieve 100% coverage, it means that the code that you're trying to test isn't as flexible, isn't as loosely coupled as you want it to be. So getting that 100% coverage is going to prove to yourself that your code is flexible, it's all separated, and it's all clean. Regression tests. 100% code coverage doesn't necessarily mean that 100% of the functionality is tested. If somebody finds a bug in your code, the options are either a test was wrong, a test was incomplete, or a test was missing. You got to fill in the gaps as you go. If you don't, you're going to be fixing the same issue tomorrow. Tools you can use. For unit testing, I use PHP unit. Continuous integration, which are just kind of service tools that will run your tests for you. Travis CI is a good one. Circle CI is a little bit more involved and a little bit more powerful. For code coverage, Coveralls does really well. Travis CI and Circle CI are set up to directly push to that, to coveralls.io if you want to configure it that way. So you can run your tests on Travis CI and have Travis CI push the coverage details over to Coveralls, and that lets you get a good idea of what your coverage is like and how it moves over time. When things change, people need to know about it. Following a versioning system is going to let people know quickly what's changed, what's updated, and whether they're safe to update. Just follow SEMVer, Semantic Versioning. It's got a major number, a minor number, and a patch number. We all know this. It's iPhone 9.1.2. Everybody uses SEMVer. You increase the major version when you have incompatible API changes. So if somebody's going to upgrade to the next major version and their code's not going to work, or if somebody needs to upgrade and the next upgrade is a major version, they should expect something to break, is what I mean to say. So minor is API changes that are otherwise compatible. So you might add some stuff or take some stuff, not take some stuff away, but you might add some stuff or change some stuff in a compatible way so that if people upgrade to the minor upgrade, they're not ever going to have broken code. And a patch is a bug fix. So usually you increase the patch number for everything else. It's usually hot fixes or security releases. Remember that with semantic versioning, it's actually unstable until you get to 1.0.0. If you find a project that has version 0.1.9 or something crazy like that, remember that it doesn't actually follow these rules and is subject to change. With Composer, you can just use git tags. So Packagist will, every time you push up a commit, Packagist will look at your repository. It'll look at all the tags you have. It'll see that you have this 1.0.0 tag, and it'll say, okay, this commit must be version 1.0.0, and it'll manage releasing that for you. Composer also has stability suffixes that kind of gets into power user stuff. You don't necessarily need to use them. I really haven't used them. But it lets you say what kind of stability the version has. So you can release a developer version. You can release just a patch version, an alpha, beta, or various RCs. So you can do RC1, RC2, whatever. Documentation is probably the most difficult thing on the list to keep up on. Technological skill and communication skill aren't necessarily something that go hand in hand. That Venn diagram doesn't really have much overlap. So trying to come up with natural language text that really describes the feature and code examples is far more difficult than you might think. If you've been listening, though, you're already partway there because good code can document itself. If you keep your methods short and your complexity low, if you use PHP doc blocks, if you keep your code clean and readable and you keep your tests up to date, your code's already going to have a fair amount of documentation, and anybody who searches through there is going to be able to find what they need. So you got to keep your complexity low. What does that mean? Check out the code block on the left. That's got a lot of paths that it could follow. It calls that fiddle function quite a few times. So if I'm looking at this, my brain is just completely locked up. I don't know what's happening, and it's going to take me a second to sort all this out. But if you look on the right, this function is essentially the same thing. That do A function, the handle B, the handle C, handle D, those are just those extra blocks broken out into their own functions. And that keeps the complexity, the actual cyclomatic complexity of this function low. So that when your brain looks at it, you say, oh, if A equals B, do A. If C equals D, handle B. You're not trying to figure out else switch Z, case fiddle break. Yeah, sure. Those are things that need to be broken out into their own functions so that they can be clean and easily parsed with your brain. So use PHP doc blocks. This highlighting is horrible. But this doc block, if you look at it, we've got a title up here in the top. It says prepend a string with foo. We got in the description of the doc block, we have a code block that shows how to use it and what happens, what to expect. And then we've got the parameters listed with the types that they are. And then we've got a return listed with the type and an explanation. If somebody stumbles across this function, they know exactly what it does. They know how it's supposed to be used, and they know everything that it takes. But that's not enough. People think it's enough. It's not enough. Nothing's going to beat a natural language explanation with code samples. Recently, in a talk by Phil Sturgeon, he mentioned that he takes about 8 hours to document a single feature. I think he might have said 8 hours per page. That's insane. But good documentation is something that you can know when you see it. So let's take a look at this. This is an example of something that's pretty complex at first glance, but it somewhat looks inviting by this layout. You can see there's a title of the feature. It doesn't list the title of the class. It gives us a title of the feature, Mount Manager. This is a manager for all of our mounts. It's got a natural language recipe for setting up this Mount Manager. It says, setting up Mount Manager is easy. Now we do all the file operations, etc. This makes something that's seemingly complex, like a Mount Manager, and makes it much easier to consume than something that is like this. This is an API documentation that was generated straight from code. So this is pulling from that PHP doc block that we looked at earlier and generating an API page for it. This gives us a lot of information, but it's really technical information. It takes something that's technical and makes it feel more technical. For some people, this is the right documentation to have, but for most people, it's just not enough. You got to have both. So that's all I have in this talk. I wanted to take this time to set up a quick example of all of the things that we kind of went over. So I'm going to take this project here and sort of break it out into its own thing, into its own composer package. So first thing, step back, make a new directory just called issues. Composer has this neat tool called init. It'll walk you through setting up your package. So this first thing it's asking me for is the name of the package. It requires a vendor, which is going to be your vendor name. Usually it's just your GitHub username, and then the name of the package. I like to put my vendor as Buttress just because it's trendy and cool and makes me look hip. And I'm going to use issues as the name. So for the description, I'm just going to leave that blank. Author, Matto. Minimum stability. This matches up to those stability tags. Stable is just the lack of a stability tag. So stable is what I want to go with. I'm going to say that this package type is a library. License, I'm just going to use MIT. And I'm going to say yes for my dependencies. Let's go GitHub API v3 again. Find this GitHub API package. Oops. So now it's choosing 1.6 for that package. It's asking if we want to require dev interactively. And we do. So we want to actually let Composer handle setting up PHP unit for us. So just that first one is PHP unit. So I'm going to put in 0. Let it choose the version for me. It wants to use 5.2. So now it gives me the full JSON output here and asks me if it looks right. I don't really know what I'm looking at too well, so I'm just going to say yes and say ls to see what we have. We just have the composer.json file. So let's run composer install. Now it's looking at that configuration file we just generated and it's installing everything that we need. PHP unit actually has a lot of dependencies, but since we did require dev for those will only get pulled down if you're running Composer install on a development environment. Everywhere that's production, you should use no dev, the no dev flag. Now we've got a composer JSON, a composer.lock, and a vendor file. This is kind of more familiar because that's what we had before. So first things first, that, and make ourselves a source directory. In this directory, we're going to have a single class. It's going to be called issue outputter. Get rid of this automatic doc block. Hide that. For our namespace, I'm going to use buttress \issues. The fully qualified name for this class is buttress \issues \issue outputter. I'll give this quick function here, and I'm just going to do this. You notice my IDE here is kind of managing keeping this all PSR2 for me. I'm not having to focus on this at all. Okay, so now we have a class that's going to be outputting our issues for us. And we've got all of our stuff, but we don't have any code that's going to actually try to run this. So what we're going to do is we are going to make ourselves a test directory. We're going to use tests to run our code here. We're going to call this a issue outputter test. This nonsense. We'll just leave this unnamed spaced for now, since we don't need to load anything in the test directory. So we're going to add a new, need to extend framework test case, and we're going to add a new PHP unit test method, test output. We're expecting to give this outputter an array that contains a title, and we want to get a string back out of it. So let's test that happens. I'm going to start an output buffer. Result. And now we're ready to test this. So we'll say assert equals. We want this to say issue test issue. This is what we would expect our outputter to output. Now, PHP unit requires an XML file to run. So we're going to add a quick PHP unit file. I'm just going to grab something from Google, if I can find something. I swear I had this up. All right, so I just went to Google and found something. I'm going to strip out all the stuff that I don't necessarily need. All I need to tell it is to I need to tell it is to load up this vendor autoload file, and then to look into this tests directory to find the tests that we want to run. So now we can go back to Composer and actually let Composer run our tests for us. So we can do that with a script. Just say test. When we want to run this test script, just go to vendor/bin/PHP unit. Let's run that file. Now, if we head into our directory, let's see what happens when we run Composer test. Looks like our test failed. It's because we didn't add our auto loading. So when we generated our init file or our Composer JSON file, we didn't actually add any auto loading. So let's do that. Auto load. Just going to use PSR for auto loading. And then we're going to say anything that starts with buttress issues. Let's map that straight to the source directory. Now that we've added this auto load file, we got to let Composer regenerate it, generate the auto load file. And now if we run Composer test, all of our tests pass. So just like that, we got an easy class set up. We got all of our auto loading loaded in. We have PHP unit set up for us. We have our dependency loaded and everything. We just have this one class in here and just enough code to test it. So let's see about getting this up on Packagist. So first, I'm going to clear this window, and I'm going to initialize Git. Now I've made my project a Git repository. I'm going to add forget what that command is. Git remote. Git remote add origin, and then I'm going to set it up with this new remote that I just set up on GitHub. So now that I have that, I can add everything. But you'll notice that it wants to add this vendor directory. We don't want that. We want everybody. We don't want to have to track our vendors. So let's add a git ignore file. And in that, we'll say just ignore the vendor directory. Now when we say git status, it doesn't show vendor anymore. So we can add everything. Commit it. We'll git commit it. Title initial commit, and then we'll push it up. So now we've pushed this up. We have it live. It's on GitHub. So we can head over to Packagist. We can sign in with GitHub. And then we can hit submit here. So it says there's similarly named packages and asks me if I want to change the name or if I want to maybe just go with those packages and not upload. So instead, we want to upload. Let's just submit it. So now we're done. This is on Packagist. It's got buttress/issues, but we don't have any releases. All we have is this dev master here. So let's quickly make a release. Say git tag 1.0.0. git push origin master tags. Now that we push that tag up there, now that we have that tag up there, it now shows 1.0.0 for our stable release. So the final thing we're going to do here, take a step back. We're going to go into our C5 issues and start that over. So let's get rid of C5 issues, and we're going to use our own dependency now. Now we're in the C5 issues directory. It's empty. We're going to say composer require. Now I'm going to type buttress / issues. Apparently, since that search is not updated, it won't find it. So we'll just enter it manually. Leave the version blank. It's going to see if I can find that. And it's going to say that it's going to use version 1.0.0. Uh-oh. Let's go back here. So I just copied this composer require command here. Let's run that and see if that works. Yeah, that worked. That's weird. So it must have just been the cache for that or something like that. So now we have required our buttress / issues package. This is what we just uploaded. So now this package, the C5 issues package, its only dependency is the package that we own and maintain. Even though that's the case, it actually pulled down GitHub API, Guzzle, Symfony, Event Dispatcher. Since we're not actually pulling this as dev, we're pulling it as a dependency, it's not going to pull down the PHP unit. So now that we have that, let's do the same thing again. Let's go back in our C5 test here. Add a file, issues.php. Say require /vendor /auto load PHP, and remember that's everything we need to load in Composer. Now we can say outputter equals new issue outputter, and say client equals new GitHub client issues equals client Now we've recreated that same file, but now we're using our buttress issues issue outputter. We don't actually even have a source directory anymore. We're letting that output. So let's see if this actually works. All that. You can see we have the composer JSON, composer lock, and now that issues.php file. So let's run it. And just like that, it works. Anytime we want to get that issue outputter, we've got that dependency available on Packagist to use anytime we want. So that's all I've got for you. Composer can be extremely valuable, extremely powerful, and can definitely save you a lot of time. So give it a shot and use it. Check me out on Twitter. Hang out in IRC. I'm always in there. And check out the concretePHP user group. We're a PHP user group for Concrete 5 developers and other developers who are not Concrete 5 developers, all helping each other to get better with PHP. And we hold these meetups every once in a while. So join there, engage in the mailing list, and yeah, we'd be glad to have you.
Yes. How was that?
That's amazing.
I didn't know if that was going to be live or not.
I think it's live. Yeah. I think you're being heard too. So yeah, that's all. That applause was live. Unfortunately, though, I think you've given up the secret, and now people know that it was fake applause. So we got a few people in here. Any of you people? Looks like you have your mics muted. Do any of you three have any questions to ask?
I'll ask questions.
All right. How's the YouTube stream looking?
It's good. You have a decent amount. The applause was awesome. Everyone likes the applause.
Whoa. I went to it and wow, that was my voice.
Oh yeah, I had that on as well. What is the PHP-FIG?
The PHP Framework Interoperability Group is the PHP-FIG. It's a group of representatives from projects around PHP, things like Symfony, Laravel, Doctrine. If you know it, they're in it. The one exception that might be surprising is WordPress, but they're not necessarily a PHP community kind of project. But we come together and we make standard recommendations that everybody can use to increase interoperability. And what interoperability is the ability to say that this class from this project can be used in my project. It can be used in your project. It can be used in everybody's project because we're all following these standard recommendations. So that's what the PHP-FIG is and does. Some of the recommendations that we probably have all heard of are PSR1 and PSR2. Those are the code style standards that I talked about. PSR1 is the structure of the code and where to put your namespaces and whatnot, while PSR2 is more code style, things that are not necessarily functional changes, just subjective, put your space after the if and everything like that. And then finally, the other one that everybody knows are PSR0 and PSR4. And I talked a little bit about those. PSR0 is the legacy deprecated auto-loading standard recommendation, and PSR4 is the new, not really new, but the non-deprecated auto-loading PSR that everybody uses. So.
Sweet. You talked about some versioning a little bit. So where's concrete5 with all of?
With semantic versioning?
Yeah.
Well, we follow semantic versioning largely. The one thing that has stifled semantic versioning with the concrete5 ecosystem is that we tend to add that 5 from the end of concrete5 onto the versions. So instead of saying version 6.2.1, we have version 5.6.2.1. So people who are expecting that to be semantic versioning will say, oh, that 5 didn't increase. It's just 5.6 to 5.7. This is a minor version. There's not going to be any breaking changes. And then they update, and turns out that that really wasn't a minor version change. That was a major version change, and we just have this nomenclature that causes confusion.
So when we release version 8, are there going to be any backward compatibility issues?
There might be. Yeah, there might be. There's certainly going to be some stuff in there that will change underneath some people, but we're trying to be better about documenting what's going to be backwards incompatible there. And it's not going to be anything like what 7 was. Version 7 was so far backwards incompatible that we didn't even offer an upgrade for it. So
version 8 will be able to do the one-click upgrade?
Yep, version 8 you'll be able to upgrade as much as you want.
Sweet.
All right, well, doesn't look like
all right, Corbin, you did a good job.
I think we're all set.
I liked your slides.
Thank you.
Oh, we got one more. Someone just joined.
Hang out? Ooh.
I think so. Daniel. Hi, Daniel. He's just breathing heavy.
trying to absorb it all. It all happens so fast.
Okay.
All right.
I'm going to get off. Time to eat lunch here.
All right. Well, thanks everybody for showing up. Give concretePHP a check. It's pretty sweet. More people and more discussion there is only going to help us. So hang out there for information about meetups to come and some more interesting stuff that's going on. So give that a look. Check out concrete5 if you haven't. It's kind of sweet. And yeah, thanks for watching.
Bye-bye.